Hi everyone, algebraic expansion giving you a headache? Don't worry, in this video I'm going to teach you some basic algebraic expansion. So allow me to start off with one very easy example. So the first example would be 3 opening bracket times x plus 3y. So this whole thing is in brackets. Okay, so in algebraic expansion, what happens is always you'll have two terms in the bracket multiplied by something. So this is the basic idea of algebraic expansion. So in this case, you have a very basic question here. We have a 3 multiplied by the x and a 3y. So how do we go about expanding this? What happens is that we have to see that when there's a bracket, we have to look what's inside the bracket. And expansion always comes after simplification. So to do an expansion questions, you must have a good understanding of simplification first. So if you have a good understanding of simplification, you can see that x plus 3y cannot be simplified any further. So once we cannot simplify what's inside the brackets any further, then only we can go on to do expansion. So now this can't be simplified any further, hence we'll expand. So what happens is, in this case, in questions like this, we have to take the 3 multiplied by the x and the 3 multiplied by the 3y. So this will then give us 3 multiplied by x giving us 3x, and 3 multiplied by 3y gives us 9y. Then we have to look at this again. We have removed the brackets and we look at this. Can we simplify any further? No. So therefore we are done with our expansion and we can just stop here. So we have successfully expanded this question and this is the final answer. Okay, now let me move on to the second example. This is going to be a very similar example to make sure that you really understand the basics. So I'm going to say 2 multiplied by 2a minus 9b. So again, recall, inside the brackets, we can't simplify any further. So therefore, we can just straight away go ahead and multiply. So we multiply by, again, 2 multiplied by 2a, 2 multiplied by 9b. So this gives us 2 times 2a, 4a, 2 times 9b, 18b. So therefore, this is the answer. We have expanded on this question and gotten this, and this is the final answer. Because we cannot simplify this any further, this is an a, and this is a b. Next question. What happens if the front number is a negative sign? Let's see how we approach this. If the third example is as such, how do we go about? It is slightly more tricky because it's a negative 7, but the same rules apply. X minus 2y cannot be simplified further. We always look at this, the terms inside the bracket first before looking outside. So that's why I'm focusing on x minus 2y first. So we can't simplify it any further. Therefore, next we will just go about multiplying. So now we have to multiply negative 7 with x and negative 7 with minus 2y. So negative 7 with x just gives us negative 7x. And negative 7 times negative 2y. So the tricky thing here is that when a negative multiplied by a negative number, it becomes a positive number. So therefore, this will just become plus 14y. And then again, one last step, we look at these two numbers, these two unknowns, and we ask ourselves, can we actually simplify any further? No, we can't, because this is x and this is y. So therefore, this is the final answer. Let's move on to our fourth example. In this fourth example, there are many negative terms. As you can see, this negative, this negative, this negative. So I really want to give you some exposure to multiplying with two terms that are both negative, because this is one very tricky and common mistake that I have seen my pupils encounter and this is mistakes that they make. So I would like that you do not repeat them, so please pay careful attention. So negative 3 times negative 2x, this will give us 6x, because negative 3 times negative 2, both are negative, they will cancel out each other, and therefore it becomes just 6x. And again, negative 3 times negative y, this will give us, both are negative, so this will give us positive. So this will give us 3y. And this will be the final answer. Now, what if I were to expand an equation or terms that have fractions? So this would be the example. Let's say we have half x multiplied by 2x minus 8y. Okay. So you see, this is a fraction now. So we mustn't think that the laws have changed. So the rules actually still apply, it's exactly the same. We just have to, again, look inside the brackets. Okay, it can't be simplified any further. Now, we just multiply this term with this term, this term with this term. So therefore, half x times 2x, this will just give us x squared, because x times x gives x squared, and 2 times half gives us 1. So I'll just put a 1 here. Okay, but in maths, we don't like to show 1x squared, so I'm going to remove the 1 now. So I'm just going to write it as x squared. So it's okay if you write 1x squared first in your workings, but later on, in your final answer, please remove the 1. That is just because it is the standard way we express mathematical formulas and mathematical answers. So please remove the 1 in this case. So okay, next step, we're going to do half x multiplied with negative 8y. So this will give us x times y gives us xy, and negative 8 times half, so 8 divided by 2 will just give us 4. So this is the final answer again, because we can't simplify it any further. This is x squared and this is xy, so these are different from this. Okay. So I'm going to go with this last basic example here. What if we use now negative 1 over 3 f times 9x plus 3y. Okay, so we have to multiply this with this and this with this again. So now f multiplied with x will just give us fx, and 9 multiplied by negative 1/3 will just give us negative 3, and then negative 1/3 f times 3y will give us negative 1y f. I forgot the f, but yes, the f will be here also. Okay, so now we do not want to show negative 1yf, because in algebra we don't want to put a 1 in front of some terms, so we can just actually remove the 1. It is the same thing. So this will be our final answer. I hope that you learned the basics of expansion here, and please like and subscribe. Thank you.